Hello there. Today we will be going through identifying common question types in H2 chemistry and learning how to answer them. So firstly, we have to identify two types of common questions that always appear in the H2 examinations. And these two is actually the two categories of H2 chemistry exam questions that may appear. So the first is qualitative common questions, and the second is quantitative common question types. So of course, the vast variety of such question types across all the more than 20 topics in the H2 syllabus means I cannot go through for each question exactly what to do. But I can teach you a strategy to identify these question types and how to prepare for them on your own self. So for qualitative common question types, normally it requires you to write out an answer on a few lines, right? And usually does not involve or involves only minimal amounts of calculations. So to be able to master such qualitative questions, we have to do two things. Memorize the keywords that always appear in every topic. For example, keywords in the topic of arenes will be things like the aromatic stability of benzene, right? Electrophilic substitution, and as well as maybe keywords related to the idea of resonance, for example. And the second thing, after you know what are the keywords that often comes up for this particular topic, is to memorize the steps to answer the common question types. For example, common question types that you will see in the A-levels examinations for H2 chemistry will be, for example, trends across the periodic table. For example, the trends of the stability of the group 2 carbonates, right? As well as questions pertaining to how resonance affects the reactivity of chemical compounds. So let us take a look at one JC1 common question, which is how does atomic radius change across a period? So there's 4 steps to answering this question. The first step is to say how nuclear charge changes. So across a period, the number of protons increases, hence nuclear charge increases. The second step is to take a look at shielding effect. Does it change? By much. We observe that across a period, the number of electrons also increases. So shielding effect should increase. But as these electrons are added to the same outermost shell, the shielding effect remains approximately constant. Then the third step is to harmonize the first two steps together to talk about effective nuclear charge, which is nuclear charge minus the shielding effect. We conclude that effective nuclear charge increases across a period. And this results in increased electrostatic attraction between the nucleus and the valence electrons, thus causing the atomic radius to decrease across a period. Now for quantitative common question types, of course there's no keywords to memorize since quantitative questions involve the manipulation of numbers and mathematical formulae. So we first need to understand the approach, understand how to approach various kinds of questions. For example, construction of Born-Haber cycle, right? Calculating KSP from solubility and calculating solubility from KSP. Finding which salt precipitates first. Finding the equilibrium constants of a certain chemical equilibrium, right? Deducing the order of equation from a table of initial rates. All these are very common quantitative question types. So you need to understand how to approach this kind of question by both looking at past examples and referring to the answer keys of the past examples, as well as proactively getting down and practicing those questions themselves. Lastly, or more specifically rather, understanding the approach requires understanding the steps. Each step follows the previous step in a logical process. So we break down the approach into a few steps. And so, because each kind of quantitative question can have various permutations, sometimes these steps have to be shifted around based on what values are known and what are unknown. But still, the fundamental steps should stay the same. So this is how to answer common question types in the H2 chemistry examinations. Thank you.